Earlier this year, we saw a tweet that read, "Who is the next Elon Musk?" Several of the comments read simply, "Ethan." They were referring to Ethan Thornton and Mach Industries, a company that has been quietly working to equip the United States for our next major conflict. In recent years, the widespread use of drones has changed warfare. Some have compared it to the advent of the chariot, or gunpowder. The US needs to develop not only our strike capability, but also our production capacity. This is the challenge that the Mach team is tackling.
So this is our principal product, Viper vertical takeoff cruise missile, primarily Army customer. This is our Rev A, so we've done horizontal flight right now. We're currently designing Rev B to be online in the next few weeks. So by the time y'all watch it, we'll actually be flying Rev B. But we've in-housed all of this. So we're doing the jet engine in-house, we do full fuel system. This is carbon fiber. We do all the way up to tooling. And very exciting sort of Army use case here for distributed long-range strike.
Yeah, it's the goal that like these guys take these out in the field on a Humvee or something like that.
Yeah, I mean there are a number of different ways you can deploy it. The goal is to like completely distribute it so that depending on sort of what your logistics looks like, it's very, very, very flexible.
I saw, I think in a video over there it is, I think.
Yes.
One taking off of the back of a truck, is this it?
Yeah, so if you look, it'll eventually have thrust vectoring control. Okay. By the time this video gets released, it'll be thrust vectoring control.
Sure.
For the first flights, we're just trying to confirm aerodynamics, and so we're doing, truck launch.
Nice, that's cool.
We'll likely ultimately actually do one that's very pared down, fiberglass, and is truck launch. Okay. But right now, our customer is very excited about the VTOL application.
Yeah, for sure.
What are the battlefield situations where you would put this to use?
I mean, long-range strike, so past the range of, most loitering munitions currently in the arsenal. It's trying to do sort of hybrid mission set between what you have with HIMARS, which is sort of truck launch, rocket artillery, requires a multi-million-dollar, like very centralized launcher. And so having a lot of the flexibility that you get with loitering munitions, with similar range and sort of speed to HIMARS or some of the rocket-based stuff.
Yeah. So folks in the field think of this. It looks like, it is a drone, but it's a missile.
Yes, it is.
That's what it is. Right.
This platform I'm super, super excited about. So our goal is to invest in flexible CapEx. So we right now can retool a new OML in about 3 days, which means we can actually like change the shape. Airfoils, it's a very, very fast iteration pace. We're initially targeting one way as a cruise missile, but this is a program we're ultimately looking to build into a reusable munitions dropper.
Okay.
Think of it as like a generalized, very, very low 6 figures, potentially 5-figure reusable fighter jet.
Okay, awesome.
But we have a really exciting customer with the Army for one way, so that's what we're attacking first, to just move quickly and generate revenue.
And other than that, we'll get into the factory here in a minute, but other than the flexibility of manufacturing, production, capabilities, and speed, cost is a huge deal with these, right?
Absolutely.
Compared to like what you said, the Mars or a Javelin or something like that.
Yep. I can't say the cost, but it's significantly below really anything in the arsenal right now. Sure. Right now we're capable of producing about one a day, just with our very, very small team. This factory we're building out will be able to get, depending on sort of what customer demand ends up peaking at, but on the order of thousands a month capacity out of the factory.
Yeah, that's awesome.
So the goal is really just to build for scale.
Mm-hmm. Yeah, that's cool.
Yeah.
And so,
so what
about these guys?
This is a glider. I can talk less about this program, but essentially a gliding munition. So right now we're using it to develop a lot of the avionics comms packages that will go on Viper. We've flown this on military test range, continuing to build out this program. I'm very, very bullish on sort of the stratosphere for the future of warfare being potentially the most important sort of domain of the next century. And so this is our entry into a line of sort of stratospheric systems that we'll continue building out for the next decade.
Yeah, cool. So that one's not a stratospheric vehicle?
No, so this one will end up cruising. We're still running the trades for where it's sort of peak efficient, but around 35,000 feet.
Okay,
And this one's higher altitude.
Yeah, for sure. Stratospheric, literally. Yeah, awesome.
Yeah.
Cool. Should we see the factory?
Yeah, let's do it.
Cool. Do y'all want to show this or no?
Sure. Yeah.
Sure. Yeah.
Why not?
Cool. Actually, we can just go upstairs. Sorry.
Yep. Whatever. Where do you want to
upstairs has a cool view.
Yeah, that sounds great. How many folks do you envision having all total here when it's built out?
I imagine this being our headquarters for a while. So we'll continue to build out mezzanines over the shop floor. Right now we're about 50 full-time with 25 interns. we're kind of close to sort of peak. So right now, this is all the engineering. And so we have aero, software, mechanical up here.
Yeah.
Really cool view. I can take y'all over. Yo, how you doing? But we have a really cool view of sort of shop floor. And so again, we just moved into this factory. By the time this is released, it'll be a lot more built out. But right now, we have all the prototype capacity to support about 1 a day of both airframes, and then continuing to build that out. So validating processes here. Behind this wall is where a lot of sort of the more IP-sensitive stuff happens, and then building out over the shop floor.
Yeah.
Very
Questions?
Cool. What's the cycle time in terms of testing those products? How does that work?
Yeah, so we do sort of rev schedules. And so it'll start with pure conceptual design, right? So Rev A of both vehicles are what you just saw. So Rev A for both was roughly confirming aerodynamics and then rolling in a lot of the base subsystems. It'll go sort of notional design purely in the performance GNC loop. And then you go to aerodynamics, spit out what's called the outer mold line, kick it over to mechanical. They design sort of all the inners of the vehicles. And then once you're building vehicles, we flew glides every day for several weeks. Yeah. Capture your data, and then completely go back, blank slate, start over again. And so right now we're generating OMLs for both vehicles in the next few weeks. But we're completely revving each vehicle every 2 to 3 months right now, which is a pretty fast cadence.
Awesome.
And so we'll push both of those to product, and they're very excited for some of the next gen stuff that we're already sort of spinning up internally.
So every 1 or 2 months, essentially, it's a completely new version of it. Yeah. So the thesis is like completely replaced every part. That's awesome.
Yep. And you can only really get that speed by in-housing stuff.
Sure.
Right.
We'll end up building 20 or 30 of that airframe within that 2-month period. And really, it's rare that any 2 of those vehicles look the same. Like they're completely sort of iterating. And then Rev C of both designs will be our like pure design for manufacture. So you do Rev A, which is kind of roughly like validate aero, validate sort of flight regime. Rev B, which is when you pull in all subsystems, sort of confirm performance, confirm full mission set. That's when you start like doing true customer demos. We have flown in front of the customer. And then Rev C is whenever you sit down with the full manufacturer team and go through the CAD again, and then actually go and build out the line.
So at that point, you're just cranking those out.
Exactly.
Out. Yeah, that makes
So
sense.
the whole system is set up right now for iteration, for R&D.
Yep.
And then once you hit a certain phase, you'll swap over to just production.
Exactly. But a lot of the processes we're going to be using for production are already being used for R&D. So like our composite tooling that we're using, a lot of the metallic, subtractive, and on the additive side, like those are things we'll directly scale. Obviously, it's pretty manual right now, and we'll end up eventually automating. I'm trying to push the automation off as long as we can. But I'm very excited for scale. And then this will, again, become the R&D shop for our next round of products.
Yeah. Why do you want to push the automation off as long as possible?
Specifically in defense markets, iteration speed and sort of flexibility are so important. Like if you look at Ukraine, those platforms are changing on a bi-weekly basis, basically. Automation's awesome if you're going to make the same thing 10,000 times, but if you're trying to iterate super quickly, you want to stay manual as long as possible. Which was part of the move to Huntington. It's just because the technician talent out here is so incredible.
That makes sense.
It's almost harder to design a manufacture process, though, to be non-automated in certain ways.
Like to get the process right first.
Yeah, exactly.
Then you can automate on top of that.
Yep.
Yeah, that makes sense. What are those little huts over there?
So we're building out all of our clean rooms.
Sure.
We wanted to get working immediately, so
Okay.
those are from Home Depot, and we're doing positive pressure, and just there are working clean rooms for the next few weeks.
That's
Nice.
cool.
We went from moving into the factory to having CNC machines set up, and like making our first airframe in about a week and a half.
Amazing.
Which I was super excited about.
And that was how long ago?
That was 2.5 months ago.
Okay.
We're at a point now where we're kind of paused. Like we have all the capability to support Rev B. Right around when Rev B starts flying is whenever we'll build up the line. So we've confirmed we're running power right now. We're setting it up, but we're waiting for Rev B to sort of validate before we
So
go.
that's when you start getting ready for
a ton of
mass
capital.
manufacturing.
Yeah.
Right.
Exactly.
Yeah, that's cool. Yeah, so this will be, I remember last time we looked at this, you have lined out with tape.
Yeah, we can go over here.
And we'll
I'll
go
show
over
you.
there.
Yeah, let's check it out.
I like it looks weirdly empty right now compared to what it will be for the next few
Absolutely.
years,
Yeah.
like decade, you know?
Yeah, we have. So this is our Viper line taped out.
Wow.
So this line we have designed will support many Vipers a month. So composites back left. Here you see a lot of the sort of bonding and automation for actually assembling the frames. This includes fuel system, machining metallic additive for the jet engine, sort of over in the bottom left.
What's the process for planning all this? Like, you have it all in your head, but how did you actually create all of this?
So our scale team is mostly automotive folks. And so the guy leading this process was very early Tesla, and then he was responsible for a good bit of sort of Rivian scaling. And so we try to be more aerospace on the prototype side and a lot more sort of automotive on the scale side.
Interesting. Yeah. Is it so? Musk has this famous line that he says that the factory is the real product. I think when it comes to Tesla.
Yeah.
Is that similar in some ways? I mean, you guys obviously have the R&D and design on the aerospace side, but when it comes to this, is the play like designing the best factory possible?
Absolutely. Yeah. I mean, I think at least for Viper and Glide, that's the play. We will do things, and we're sort of using Viper specifically as a test bed for tech on the like deep domain prop aero side that I think will ultimately have massive defensibility. But for Viper, it's how do you drive the cost down as low as possible so that we can make tens of thousands of these things.
What are some of the maybe, unintuitive ways in which a factory is not flexible? Like you might set it up in a way you think, oh, it's ready to go, and then it doesn't afford you the flexibility that you would want with a product like Viper.
So everything has a cost. The cost of flexibility is actual true like BOM cost. So like an example would be metallic subtractive versus aluminum injection or die casting, right? At let's say 1,000 units, that die casting is going to be cheaper than aluminum subtractive. The advantage of the flexibility on sort of just the metallic subtractive, and this is not obviously anything we're claiming to have invented, it's more of just an investment thesis, is that you can rev a lot faster. Even while you're producing, you can start making pretty significant changes, and it allows you to not have upfront cost on new revisions. The interesting thing too is that then that CapEx can potentially be amortized over several products. So a lot of this factory actually is also directly supporting Glide. And so when we look at capital efficiency as a company, it's all about lining, if we're a manufacturing company, most of our capital spend will be on manufacturing equipment. And so lining that up against both current products and future products.
Yeah.
So
Awesome.
thank you. It's going to be really, really exciting to see it rolling out product here in about a year.
Yeah, man. It's going to be sweet. Any key things you guys have to change to the building, or will have to change to the building for it to get to where you want it to be? Or
not a ton. We'll be dropping a bunch of clean rooms in. This place will look nothing like it looks now.
This is crazy empty right now.
Yeah, we'll be dropping clean rooms in. This will end up being a lot more built out as sort of just inventory. You see cages roughly going up, but that'll be relatively controlled.
Okay.
Way in the back, we have a couple connexes now where we're testing our jet engines.
Okay.
So we're firing a jet engine about every 2 hours right now. That'll end up being like its own sort of facility. This is all, it all gets incredibly expensive. Like just running power for this facility right now is like $2.5 million. And so we got
right now without the machines?
So we're preemptively running power to be able to scale quickly.
Okay, got
so
it.
the game you're constantly playing is DoD sales cycles are kind of a chicken and egg.
Sure.
Like you won't win the contract unless you're capable of scaling, but you don't want to invest in scaling unless you win the contract.
Yeah, of course. Right.
And so for us, it's sort of rolling that out in tranches that stay flexible for both of our products.
Right. That makes sense.
And so yeah, I mean we're running power right now.
Yeah.
We got super fortunate with this building. We have 4,000 amps. Like it's a really great place to scale. And like I said, I imagine continuing to just build out mezzanines and having this ultimately be our prototype shop for all of our products, and likely setting up very large factories elsewhere.
That's sweet.
How'd you all find this building, and what's the history there?
I wish it was more interesting. It was a good building.
It's just a big old building.
Like we just need a big building. Yeah.
We got a great rate on it. It's old, so it was old Boeing that got torn down, and so we're the first tenant, which is super nice. A lot of the old Boeing sort of machine shops and suppliers are out here, which has been super helpful, as well as obviously their labor force.
Okay, so wait, was the building built fresh on an old Boeing site, or was it?
Yes.
Okay,
Yes.
Got it. Okay.
So the building was finished in like February,
Got it.
Okay,
and then
wow.
we pretty much moved in a couple months after
Yeah,
that.
nice. That's sweet. What are those guys over there?
Oh, yes, whenever I talk about major revs, this was the last rev of Viper.
Oh, wow.
Like, I literally mean they look significantly different.
Very different.
Oh, so the Viper that you just showed us down there was this
Yeah.
is the one before.
Like,
before.
I'm not joking about like back to the whiteboard, challenge all assumptions.
Amazing.
Wow.
I think, so we made our first full-time hire like 14 months ago. And so it's also like all of these teams are being built while the product is being built. So when we did this rev, we had one aerodynamicist, and it was like my buddy from MIT. And so our knowledge has increased like crazy. The guy leading the aero team right now was like SpaceX for 12 years, and we have like 5 people. And so that's where you saw the next rev, and then the next rev will be even better.
It's striking that the current rev is like way more aesthetic than even this one.
Yeah, and I think the next rev will probably be uglier than that rev. Like, and aesthetics are important. I care deeply about sort of creating things that show deterrence, but at the end of the day, like physics is physics, and we have to create things that the warfighter will want to use.
I'm curious, the stuff that you can share, what from this worked, and then what from this that you thought would work, you had to delete and get rid of?
Yeah, this thing was pretty stupid, to be honest with you. It's kind of built like a dump truck. It's surfaced horribly. Like you can literally see like chamfers in the airframe. The thrust vectoring system is like completely different architecture now. This is an old off-the-shelf engine. We're in-housing that. The composites process was pretty shit. You see, yeah, it's not great. It was good to be able to stand up our process, but it's about moving forward. Some of the stuff, like this is where we're scrubbing our boundary layers. It's way oversized and inefficient. But the carbon fiber's nice. I mean, I'm proud of it, but I'm really excited to see the next rev.
Yeah, to the next one. Yeah, that's cool. Yeah.
Is this a version of Glide, or is this
just the backside?
So this is the other side of the.
Yeah.
Oh,
This is
gotcha.
the backside. Yeah.
Yeah, you can see how shitty the composites work was.
Yeah.
These were actually 3D printed molds, which I am proud of. So these were made on very small 3D printers, and we made these molds in about a day, and then started pulling parts off relatively quickly. So no, I mean I'm proud of. We did this when the company was like 20 people too, so it was pretty efficient.
You were still in Texas then?
Yes.
Okay.
Yes.
Yeah.
So we started this rev here about 3.5 months ago.
Okay.
Yeah.
Yeah. Nice.
Yeah.
Sweet. Should we go down?
Cool. Yeah.
Or I guess wherever Ethan wants to take us.
Yeah, we can go to the shop floor.
Yeah. That fly looks so sick.
Thank you.
Yeah.
Oh, I can tell you all one interesting thing. So there's no drywall here because we built this wall before it was legal. It was all good. Like we were working with attorneys and stuff, but it wasn't certified. So we threw this wall up. I said a week and a half. That included actually building the 20,000 square feet of walls and stuff in here. And so there's no drywall because we just got it certified, and we're going to be walling it off now.
Nice.
But it's been super aggressive, fast build. You can see the floor is super dirty from all the drywall dust from construction. And just trying to move as fast as we can.
Yeah, sweet.
But that's awesome.
I think you're fine. As long as you're flying as parallel to the
Yeah, keep that next baby. Cool. So yeah, I mean, this is our additive shop. We run about 70 3D printers. A good portion of Viper right now is additive, and then all of Glide is additive. So that's all done on these printers. We have production capacity to support up to 6 Glides a day right now, and then it's very helpful. So you can see we're printing a subscale demonstrator of Rev B Glide at the moment.
And what does additive mean?
3D printing.
3D.
Yeah.
Okay.
So I mean, there are tons. It is the future in certain ways. I think legacy processes still certainly have their place, but for instance, we're confirming aero on just a subscale of Rev B right now, and so we can print something matched in our mass, quickly go and iterate on it, even if we're not going to have the full-size airframe built for another month and a half.
Yeah, that's awesome.
So we have, basic FDM. We have some SLA. This one's cool. It's continuous carbon fiber, so you can print similar sort of yield strength to aluminum on this machine.
Print. Okay. That's
so
super cool.
It has a single, like a unidirectional filament of carbon fiber that it prints with the nylon. It's a cool machine. Mark Forge makes it.
So what of the Viper, broadly speaking, what parts does this station serve?
So this makes the inlets. This makes all of the avionics trays.
Yeah.
This makes the vertical stabilizers, the horizontal stabilizers, and then the fuel system mounts.
Okay.
And then all the metallic components we're still doing subtractive. I'll show you where we do that. So that's all of your fasteners, that's all of your sort of servo arms, actuators, and then obviously the jet engine.
Yeah, sure. Yeah. So your supply, as far as supply chain for this station, it's just plastics and carbon fiber for the most part?
For this one, this is an area that likely won't scale production. So whenever I talk about the differences between Rev B and Rev C,
Okay.
Rev B is additive, Rev C will be injection molded.
Injection molded, right.
Or vacuum formed.
Is that just much faster or much cheaper or both?
It's cheaper at scale.
Okay.
And you can get
At
better
scale,
performance.
right. Makes sense.
Yeah, so Rev B is a lot of additive. We may do SLA components on Rev C, which is what we're actually shipping.
What's
But it
SLA?
won't be FDM. Actually, it's embarrassing. I don't know what it stands for. Here's some of the machines. It's essentially, you have resin.
Okay.
Photo cures. This is actually like all hobbyist grade stuff, which is kind of terrifying.
That's crazy.
We take pride in it, right? Like we take pride in being able to use super cheap means to produce things that are like incredibly capable platforms.
So that's, resin, I see it in there.
Yeah, and then you have I think these are 8Ks. So you have like an 8K bed that broadcasts light, and then it hardens.
You want a example code?
Yes. So here's a vertical stabilizer. For
Okay,
one of these
awesome.
machines.
Okay, nice.
So you can get way better quality. Again, these are hobbyist grade machines.
Sure.
Just because we can break them and we can move fast.
Yeah.
But it's nice to be able to iterate. This is our truck. So this is the launch device you saw.
Oh, that's the one I saw in the video.
Yeah.
So we initially started with a go-kart, which I can show to y'all. Again, Viper's not designed to launch horizontally, but we wanted to get the aerodata as quickly as possible. So that's the launch up there. And then we call this trunnel. So it's essentially a giant boom that mounts in front of the truck that we have a 6 degree of freedom load cell mounted on.
Okay.
So we can drive the truck, we can fire the engine, we can move all of our control surfaces, and instead of having to wait on a wind tunnel. And we didn't invent this. I don't know of many players that do it.
Okay.
But like daily basis, we can make new Vipers, confirm aero, and then keep revving. And it's shockingly accurate. So we compared flight data to the data we pulled off of this, and it was within like a very, very small margin. Like
So you have
couple
Viper up
percent.
there, and then this shooting.
So we have computational models we use, and then we'll make subscale models, and we'll go and fly them. So we'll actually bungee launch them, see how they fly.
Okay.
And those models take a couple hours to make.
Sure.
And then we make a full-scale vehicle. We did the last one composite. I think moving forward, we'll just CNC it out of foam.
Okay.
And then you put it up here, and that CNC foam process takes, again, like 12 hours. And you can very, very quickly get like aero data only up to about 100 mile an hour. But that's useful for sort of benchmarking your models.
Yeah.
Nice. And so it's just super, super fast compared to waiting a couple months for a wind tunnel.
Right, of course.
What we're really trying to do is build the machine on Viper and Glide, but all these capabilities that we're building out, we'll be able to rapidly iterate on a bunch of different form factors.
That's cool.
Thank you.
Will you build a wind tunnel here, you think, or?
Eventually. I think for now, this works fine.
Right.
I don't think a wind tunnel is a Series B thing.
Okay.
We'll be doing higher speed things that we'll use like university wind tunnels for.
Sure.
I think someday I'd love to have a wind tunnel, but they're expensive programs.
Right.
Have there been any components in building this that have totally gummed you all up, like major obstacles that you ran into?
Composite stand-up was pretty challenging originally.
Yeah.
Our Austin shop did not have enough power to support our CNC machines for a while, so that took like 3 months to run power, which was a pain. I mean, we're not doing anything that challenging, to be honest with you. Like, this is going to be very, very hard.
Yeah.
Right.
Yeah.
But the prototype side's been relatively straightforward. The compressed timelines of like trying to hire 50 people and build airframes and win military contracts and do all that at the same time has been challenging.
Yeah.
This isn't rocket science.
So for the one that's VTOL for the new version, do you have to like stand it up on its side, or?
So we're still figuring out the exact launch mechanism, but it'll be literally set it on the ground anywhere in the field and send it.
There you go. It's nice. That's awesome.
So the goal is to keep the whole pack under like a couple 100 pounds.
Amazing.
So you can just move them around very, very quickly.
Yeah, literally, one guy can move it.
Yeah, several 100-mile range.
Yeah, amazing.
I can't say like exact numbers yet,
Sure.
but like for the costs unmatched range.
Yeah, amazing. And so this, you guys had to
put up these walls around it, right?
Yeah, we did.
Yeah. Is that for security, for noise, or?
So yeah, this will ultimately be where we do a ton of our less open programs.
Gotcha.
Can y'all hear okay with the water jet going?
It's fine. Yeah, we'll make it work.
It's Spencer. So this is a fab shop. Just kind of rough prototyping. You can see, I mean, we run water jet welding. This is an awesome machine. So this is a big 5-axis mill, or a 5-axis router, sorry. But this is where we cut a lot of our composite tooling. And so you can drop a full tooling board on here and go and cut and directly lay carbon fiber in here. So at scale, that's not the tooling approach we'll use, but in the interim, it's very, very, very fast to just get molds cranked out. So this is a big 5-axis head. It's a cool machine, automatic sort of tool changer.
That's awesome. And these machines just exist. You're able to source these.
Yeah. I mean, it's not crazy. Like a lot of folks do this stuff.
Okay.
But I'm super happy about it.
Yeah.
Questions?
That's it. No, that's just sweet.
Thank you.
How many hours? So will this scale? Will you have to scale this machine and meaning get more of these as you scale that, or
so
is one of these
this only makes your tooling?
just makes
And
the
so
tool?
there are a couple of different ways to do composites. We've invested a lot in composites, and that's one thing I won't actually be able to show you. But we're doing pre-preg. We're actually trying to get out of oven, out of autoclave on pre-preg, using some really interesting stuff on the tooling side. But this machine will be used to make tools as well as other machines. But once the tools are made, we're getting a couple hundred Vipers off of these machines. And so, yeah, this will make stuff that you'll see running down the line.
Awesome.
This is an old machine. I like this thing though. It's a giant bandsaw. I like this. This is kind of how I started the company, was with tools like this. Because I originally financed it. I mean, not a ton of money, like on the order of like $10,000, $15,000. But I ran a business in high school doing like lumber processing, metalwork, welding, making kitchen knives, all kinds of stuff. So this is a way nicer machine than I had. But this is very similar to kind of how I grew up. I've almost cut several fingers off on these
You're a badass.
things.
Yeah.
I was processing a chunk of live oak one time and I slipped through and my thumb hit and it went like a half inch in my thumb and turned into like basically like sponge. It was pretty bad. I still get to spend a lot of time in here, which I appreciate.
Yeah, nice. There's so many more plants here than there was last
They
time.
keep multiplying, way more plants. I don't know what's going on.
We can talk now, maybe later too.
Yeah.
But what is it about the composites that's so cool? Just what you can't see, not the actual parts, but what are composites? How do they figure into the process?
So
And if you can't,
there's actually I can talk about it. There's a chance Viper at scale is actually non-composite, which is kind of what makes it funny.
Okay.
Composites are awesome for flexibility. So you have stamped metallics, you have fiberglass, you have carbon fiber, and then you have 1,000 different iterations of these. If you're looking at the composite side, traditionally they're used in aerospace for performance, which is obviously super valid, cutting weight, increasing strength. They're also super useful for flexibility. So if you're doing stamped metallics, it's several weeks to months to cut a new tool, and that's how like auto bodies and stuff are made. To cut a new tool. The interesting thing about the composites process is you can do that on a day-to-day basis. Still running the trade study on what Viper Rev C ends up being. Eventually Viper will diverge and we'll have super sophisticated versions of Viper that are like RTM, and like super sophisticated composites will have versions of Viper that are fiberglass, that are truck launched, that are super cheap.
Same form factor, but the materials make a difference in what it can do. Yeah,
exactly. You're investing in the machine to be able to rapidly fit a bunch of different customer needs. First customer need is one-way Army, relatively cheap, super reliable Hellfire warhead.
Right. That's cool.
This is our machine shop. Again, it'll continue to be built out.
Yeah, sure.
I mean, we use Speedios for a good bit of stuff. Cool 5-axis machine here. So this is an insert for glide actually. It goes in one of the fins. You can see a part being cut here. If you want to look.
No, that's sweet. these are all small metal components.
Yeah, or large metal components. I mean, I'll show you. We can make pretty good sized components on this Hoss. And then this is, so if you read about the hydrogen work, we're still doing that work. I can't talk a ton about it, but this is a giant lathe. So if you were making a very large combustion chamber for a gun of significant size, this is just a giant lathe.
This is the giant one?
A giant lathe. So you
Oh, giant lathe. Okay, so you can cut, some really like that.
So line it up for some exciting.
That makes sense. Amazing.
Thank you. Cool. Other questions?
All right, great. Yeah, we can head back here.
Cool.
So we just did a factory walkthrough. Things are growing fast. Like Santiago mentioned, there's a lot more there than there was a month ago. There'll be a lot more in a month from now. But how did you get to this point? Like going back to the beginning, how did you get into this space? How did you come up with the idea of Mach? How did that happen?
Yeah, absolutely. I never necessarily wanted to found a company growing up. Like I've been obsessed with these challenges for a while. I have a lot of family members in the military. I grew up in Texas and have helped my grandpa on the farm and been hands-on. I started making knives and stuff when I was really young. Like grandpa showed me how to make a knife when I was 9 or 10. Started a business in high school just to sort of have cash to experiment with stuff, doing knife making, lumber processing, making furniture, all kinds of different stuff. Hired my buddies to just help me do that. But I knew that likely with my entire life, at least with the first sort of majority of my life, I wanted to do something to try and help solve these problems. It wasn't immediately apparent that was a company, right? I went to MIT through ROTC on scholarship to join the Air Force. I was trying to actually get a lot of the stuff I developed in high school because I used that cash to prototype mostly hydrogen stuff as well as some of the stratospheric stuff. Potentially do work with Lincoln Labs, and the company was an option. Going into it, I was 16. I had no idea how to build a company. It was very clear that there was a low probability of success initially, but potentially outsized impact. And I was able to meet a ton of awesome mentors, investors, team members who have brought that 1% up dramatically. And I think we're in a position now to have a super, super meaningful impact. But when I look at deciding to start a company, whenever I look at any of our products, I don't actually care if we're building hydrogen. I don't care what we're building. I care about the fact that hopefully it's driving towards that mission.
Right. So even in that early iteration, you were using the knives as a product to fund the other work, getting that cash flow in to fund larger stuff.
It was called Blue Oak Ironworks was the business I ran. I made $15,000 total on this business. It was not some venture scale endeavor. But yeah, I mean, growing up where I did, it was a cool way to be able to. I built the first gun. So it was an electrolyzer. It took water, broke it into hydrogen and oxygen. Combustion light gas guns, folks have worked on for a while. We've done different stuff. We're not doing what they've done. But yeah, it was a deer feeder battery, an electrolyzer on my back, and then it's $400 total from Home Depot and Amazon parts, and then a shoulder mounted bazooka that shot 1/2-inch ball bearings. It was a lot of fun. So I did that. What's up?
Could you hunt with that?
I was pretty weak. I don't know. I think it had the similar energy to a 9mm.
Okay.
I would hate to shoot a deer with something like that.
Yeah, of course.
You want to be
need
pretty
something
humane.
that it's over. Yeah, right away.
But I guess theoretically, you could have.
Yeah.
Was there anything at that point that inspired you to pursue building a company? I think most people, when you're 16, are thinking about where you're going to go to college. They're not thinking about creating those businesses. Was there any? You think it was just the way that you were brought up, or any particular catalyst that sent you that direction?
I mean, a company is a tool, right? A C Corp, whatever structure you're using is just a tool to achieve a goal. And that goal can be revenue. That goal can be impact. It became clear that if I had the resources to pursue a company, that a company would probably be the most scalable goal, or the most scalable tool of achieving my goal of having an impact, hopefully for Western defense. But yeah, I mean, companies are awesome. It's a very, very cool tool. I love building a team. I love doing all of this stuff. So it ended up falling into place pretty naturally.
You mentioned obsessions. How did you go from growing up, all of us, you hear of problems all the time, whether it's your family members about a particular industry or just stuff you run into the internet. There's just problems abound in problems. By problems, I mean cool things that you can solve, right?
Yeah.
So at what point is there a point where you're
man, there's something about this problem that like appeals to me, and where you just like double down on researching it, thinking about it,
Yeah.
figuring out how to get into it.
Great question.
Or was it a different process altogether?
No, so I would say my obsession for the problem is the problem. Like my obsession for building Mach is the fact that the U.S. needs to defend itself against a potential near-peer conflict. Whether that conflict is in 5 years or 500 years, we need to constantly be building systems capable of deterring, and if it comes to it, winning those conflicts. Now, building a company in the space right now is super, super interesting to me for reasons aside from that, right? Like we will generate massive revenue as a company. We will continue to scale. I think there are a lot of tailwinds right now with building manufacture for defense specifically, developing a lot of these capabilities and then rolling them out into sort of more public sector. I think a lot of the work we're able to do on the aerospace side will have massive advantage in the commercial aviation sector at some point. So I think it's a very interesting place to be starting a company. I think the customer is primed for disruption. Y'all had Trey on. He's way better to speak about this than I am. But if we look at what platforms are winning wars in 2 decades, it's not, and this is potentially controversial, but I don't think it's aircraft carriers, and I don't think it's B-2 bombers. I don't think it's these big centralized platforms. An F-35 is made in 1,100 different factories. If things actually start going poorly, I think it's very, very unlikely that we maintain operation of all 1,100 of those factories. And so when I look at what is winning wars 2 decades from now, 3 decades from now, it is these distributed systems. It is Anduril Fury. It is Saronic boats. It is Mach Viper, right? It is Mach Medusa. It is all of these different platforms where you can go and have the same strategic capability, but then break that down into discrete units on the battlefield that are a lot more difficult to target and to defend against, and then vertically integrate on the manufacturer side and create flexible tooling that allows you to keep producing as shit hits the fan.
Mm-hmm. What do you think will be the big so like Elon talks about how painful it was to build his factories and production lines. What do you think will be the big pain obstacles for you all?
Maybe ask me in a year.
Okay. Yeah, they'll find you.
Yes.
Yeah.
I think if you can predict them, then I would be trying to solve them. And so I'm sure the ones that'll end up hurting the worst are the ones I can't see yet. Rolling out an ERP is always super, super painful. Rolling out an ERP in an environment where you're trying to rev vehicles on the fly is going to be hard. I think a lot of the DoD compliance in terms of like Viper takes off vertically using a jet engine carrying munition. The supply chain and quality work associated there is going to be very, very challenging. We're going to have to fire up every jet engine that we produce, right? And like qualify every single engine. And so I think a lot of that will be challenging. I think it'll be difficult to be capital efficient while doing these things. Again, like if you're making cars, you can kind of set your production capacity and you can plan a year out that I'm going to be making 30,000 cars a month at this date. There's a bit more ambiguity in the defense space, which is tough. Like you'll hear customers talk pretty frequently about bulk orders, but it's kind of a chicken and egg thing where you won't win those bulk orders unless you have the production capacity. Right. You don't want to build the production capacity unless you have bulk orders. And so being able to have models that allow you to be efficient with your capital while scaling, especially as a young company of 50 people, is incredibly difficult.
Yeah. Something I noticed when we were walking around, like you have put a lot of emphasis on fast iteration. You're moving incredibly quickly, but everything is clean, everything is orderly, everything's like squared away, which is difficult to do. Usually if you think you're going real fast, you have a lot of mess. Is there any sort of a framework that you use to create that kind of a fast but clean environment?
I appreciate that, actually. I was worried that it looked like a shit show. That means a lot. It's all about having really good people. Like you want people to take pride in their workspace and take pride in their process. You have to be very intentional in setting something up and make sure that tools have a spot. Like every tool in the factory, we have like cut out to where this goes in sort of a phone holder. We have a fun tradition every Friday as a company where everyone in the office actually reports to manufacturer. And so like a composites tech will own his area and we'll actually drop 2 SWEs under him and do like a 2-hour shop clean. Depends on the length of the shop clean. Usually it's like 30 minutes, but everyone in the company will clean the entire factory every Friday evening as well. And then we'll go do
software
like
engineers will go out.
Yeah, exactly.
That's cool.
Nice.
We'll have like mechanical engineers sweeping. It's a really good way to like kind of bond as a company. And then we have a bonfire in the back and smoke cigars and stuff. I don't smoke cigars. I'm Tony.
That's awesome.
So, going back to the history of the company, at what point, even if you have this idea, you have this obsession, you ended up raising capital. So at what point were you introduced to that world to say, okay, the path is venture, and where do you meet your first VC? Like, how does that process unfold for you? Going from north of San Antonio, was it?
Yeah.
To starting Mach.
It was super fast and kind of painful being exposed. I didn't know what a VC was, and then like 11 months later, we'd raised like $85 million. So it was like very, very aggressively having to learn. My first VC call was in my physics classroom back in high school with Michael Gibson from 1517. So I was working on small arms at the time, and he heard about some of the work I was doing and like cold outreached me and actually ended up writing a small check, which was part of sort of how I got going. And then they did our pre-seed primarily, as well as
how did Michael hear about what you were working on?
So MIT campus preview weekend, you have like 4 days to go to campus and just kind of hang out. And I hit the ground running there very, very aggressively, trying to like figure out how to work with Lincoln Labs, how to do all these different things. Kind of made a fool of myself. Like I was kind of like a bull in a china closet, not necessarily in a bad way. But I think a lot of people raise their eyebrows about this, like 17, 18-year-old asking everyone how to build small arms rifles on campus. And that's kind of Michael Gibson's thing.
Yeah, that was the siren
scouts
call.
on the floor or something.
Yeah.
Somebody, yeah. Okay, so Michael Gibson, first call.
Yep.
First check-in, I suppose.
First check-in. I mean, they're like $1,000. Like he sent it to me and my friend on Venmo, because Venmo only goes up to $500. And then after that, I went self-funded for a while. And so I went to MIT. I was gonna do work with Lincoln Labs. Their IP ended up being very, very sticky. And so I cut that off and sort of lost that funding. And so I put like every last dollar I had into getting, it was again, stratospheric systems, unmanned systems, and then some of the gun work. It was primarily guns at this time.
Yeah, the original idea was, or the original product that you were focusing on
product, yes.
Was the
I had patented and done work on sort of all of them. Again, I am an engineer. Like I love building products. My favorite part of the company is product, but I don't spend a ton of time like obsessing about which specific product we're building. And so I was trying to be flexible. At that point, it seemed like guns were our best sort of tech moat.
When you mean guns, you mean like small arms? Like
so small arms initially. By the time I got to MIT, it was actually more sort of air defense type work.
Got it.
Still the oxyhydrogen. Again, a bit different than combustion like gas guns, but I was building like 20 millimeter class. And so just used the money I had from the business in high school. Got a bunch of my buddies, a couple Air Force guys, a couple football dudes, and we were able to machine a gun and then tested it under a bridge behind campus under the railroad tracks. I think I've mentioned this, I think, publicly, but it was very, very scrappy, but we got it to half work. And then based on that, went and raised our pre-seed. And then with the pre-seed, couple of my buddies kind of half dropped out. So you have MIT IAP, which is a month off. And so we had a month to like kind of establish the company. We only had like $90,000 in the bank. But during that month, we went and like actually built all the furniture for the office. Like we got stuff on track. We fired a gun. We got a couple drones flying. We basically didn't sleep. We lived in the office for a month because they had to go back to school. I had dropped out at this point. But then based on that is how we got the Sequoia round.
Yeah.
And then it was kind of scaled from there.
So you didn't go to college? I mean, you went, but you dropped out.
I shouldn't be wearing my brass strap. I wear it out of respect for the institute, but I guess it's a bit fakey. I think I filled out my dropout form in like the second week of school. It was pre-team, pre-capital, obviously pre-product, pre-customer.
Sure.
But
so you knew that soon after like 2 weeks that you're like, I'm going to drop out. I'm going to pursue this.
Yeah. And I stayed in school. So I finished the semester out. But it became clear that was the highest leverage way of doing things. Obviously incredibly risky. MIT is nice because you can always like, I would like to say I was taking some huge risk. Like I could have gone back. I would have lost my Air Force scholarship and I had to like quit football and stuff, but I could have gone back to school. But yeah, I mean, I have strong conviction in what we're working on, and I figured I don't do things halfway, and so it's something I wanted to do, so I did it.
Yeah, man.
I was curious, like, are there any, we talked about Elon earlier, are there any figures, either living or dead, that you draw on? Like, you've scaled your knowledge incredibly fast. Like, this all has happened really quickly. Is there any particular sources that you draw on to, for inspiration or models?
Great question. I have a good friend group of sort of fellow founders that are my age. The Teal Fellowship has been a great way to sort of meet people who are going through similar struggles. I think, yeah, if you're looking at like people who I think have done an incredible job building hardware companies, like Elon is A1 there. I think what he's done for humanity through Tesla and SpaceX is top tier. Frankly, from like an engineering and manufacturer perspective, my grandpa is incredible. Like I learned a good chunk of what I know from him.
What did your grandfather do?
He was a farmer.
Okay.
Yeah. So he actually, I think he finished high school. He never went to college, but he got the family farm when he was like 19. And then has just done an excellent job building. He builds and flies like experimental aircraft in his free time. And so I'd spend a couple weeks of summer helping him run the farm. Normally folks like hire hired hands, and that's how they run farms like that.
Mm-hmm.
He refuses to do that and like insists on doing it all himself, but he's like 70. And so my cousins and I would always kind of take turns helping him do that. And so that's where I learned a lot of the mechanical stuff. You wake up super early, you work, and then it's hot as shit during the day. So you go to the garage or the barn and kind of work on aircraft or knives or bombs or whatever until it cools off.
That's
amazing.
Awesome. What did your parents and folks in your like your friends and stuff thought about you dropping out of MIT?
So my parents have been super supportive. They were sad. My mom was crying. I think mostly out of just like fear and sadness. Like it was very obvious that I was going to miss like any college experience. Moms like they get sad about these things. But I think they align around the mission. And they've been incredibly supportive. Yeah, they've been good.
Yeah,
I don't have any crazy stories. Actually, I have one. Senior year of high school, they definitively said no more gun work. So I came too close to blowing myself up, and my mom pulled me into the living room and was like, "You have to stop this immediately," which I would have totally done the same. I would have done it long before she did it. It's actually amazing that they put up with the shenanigans for as long as they did.
Yeah.
But
do you have siblings?
I have 3.
Okay.
So they're all younger. So
Okay.
one just graduated high school. He's going to join the Corps at A&M. And then the others were all 2 years apart. So
Okay.
one's going to be a junior. My sister's going to be a freshman.
Yeah. So then back to racing and Sequoia round. You guys, at that point, you're still focusing on the hydrogen propulsion product. Or at what point do you start focusing more on Viper and some of these other aerial systems?
Yeah, our Sequoia deck actually included unmanned systems.
Okay.
It included, I think it had some stratospheric work in there. No, I mean, the initial, and I've got flack for this, but I would do it again. The initial sort of 6 months of the company, seed to really like 2 months after Series A, we had like 6 products. And so there's a high level of ambiguity when you're approaching the DoD as a customer in terms of what programs are going to work and not work. And so the way I chose to approach that was to sort of get to like minimum proof of concept on a bunch of different things. And so this was, at the time, this was the gun work. This was some aluminum reactor work, which I'm happy to touch on, some of the unmanned work. Again, a very large number of products. And then as it became clear what the winners weren't, we began to cut products. Because you're never going to productize 6 things as a young startup. Even 2 is incredibly difficult to do on like an 18-month timeline. But I think that if we would have tried to narrow down too quickly, I would have made the wrong bets and we would have died as a company. And so it definitely caused a ton of churn. It wasn't necessarily super, super capital efficient, but it was the best way to sort of de-risk as a company to make sure that we were building things that were winners.
What was the rationale behind raising like a big Series A, 79 million or so, versus like doing a smaller raise and then building up from there?
Yeah, I think by the time we raised, it was clear that we had customer traction. We were very, very early on the product side, but we had been executing towards a product. I would say We're a manufacturing company. This is a very, very capital intense thing to do. To go build out a factory that's going to produce a couple thousand fighter jets a month is very capital intense. And so, I mean, yeah, we're going to use every dollar of it in a capital efficient way. But I would do it again 10 times out of 10.
At what point in the process here do you, and maybe you knew it beforehand, but at what point are you really scaling up your own knowledge of large scale industrial manufacturing versus like building, with your grandpa, a few vehicles in a barn?
Yeah, it's a great question. I mean, that's all talent. So we've built a manufacturer team I'm incredibly excited about. I mentioned, I guess they haven't seen the walkthrough, but Fasil, who's leading that team, was big for sort of scaling Rivian. He worked at Tesla. He worked at Apple. We've hired several folks with that experience. Right now as a company, frankly, the most important thing is iteration rate, which is where that sort of more hacky, quick prototype is super useful. But there will be, and it's kind of happening right now, where we're rolling into like true inventory systems and stuff that hand over into scale manufacture.
Yeah. So speaking of talent, what was it like attracting talent when you were 19 or 20? I suppose the Sequoia round helped, but what is it like you were not even in Newport Beach at the time.
Yeah.
You were somewhere else. So what was that process like of talent attraction and then securing that talent?
Yeah. It's been hard. Like hiring engineers has probably been the single hardest problem as a company. But we've also, I think that's mostly because we've just mandated a super fast sort of ramp in team size.
How big is your company now?
We, including interns, we're about 75 full time.
Mm-hmm.
I think the problems speak for themselves, right? Like it is very clear how important it is to be doing this work, and so we've led with that, and we've been able to attract. I've been very, very happy with the level of talent we've been able to attract. Now there was the Austin to Huntington move, and I talked about that. I set up in Austin because it was close to a lot of the customers, and it was obviously a lot cheaper. And there's a good bit of mechanical and software talent in Austin, and then tons of great technicians. But as we began to approach more and more complex aero problems, right, propulsion, aerodynamics, some of the GNC performance stuff, it became clear that this was the area to be. And so we moved out, and I've been very, very happy with traction since then.
Yeah. What was the difference in attracting talent in Austin versus attracting talent here?
The conversion rate hasn't changed, but the top of funnel size has changed like crazy. So there aren't that many aerospace companies in Austin.
People would want to stick here in Newport Beach, meaning they weren't willing to relocate to Austin, or
yes.
Interesting.
I mean, when you're hiring someone who's got a family,
sure, of course,
it's pretty set up.
Because these are guys that have been, let's say, at SpaceX 10 years or plus. Yeah, they're sort of settled in a particular way.
I was super excited. We were able to pull almost all of the talent from Austin, and so it's rare as a company that you pick everyone up and everyone together like decides to move their lives across the country.
Right.
And so I mean, I was so grateful for the team for that one. That was an incredible sort of show of faith.
Is the majority of the team coming from primes, other aerospace startups coming fresh out of school? What does that intake look like?
It depends on the area. On the engineering side, it's almost all other aerospace startups, primarily SpaceX. On the manufacturer side, it's a good split between more traditional aero. So think primes or startups and automotive. And then on the operations side, it's a lot more sort of venture specific folks, either actual venture capitalists or operators from different companies, but not necessarily aerospace.
So I grew up around Lockheed and Boeing folks, and I know their operating standard is almost the opposite in some ways of what we saw on the floor in terms of iteration speed. They're working on 20-year programs. Is there a big enough culture clash there that those people don't work in this kind of environment, or can you draw people from primes and then slot them in?
Yeah, I think it's very popular right now to sort of attack the primes, and I think they've certainly grown sort of slow. I think when you're working on the F-35, you just need to approach problems so differently than when you're working on Viper. We've had a couple of engineers join, and they're some of the best team members we have, but it's definitely a smaller percentage, just because it's culturally so different.
Yeah, makes sense.
What about you made a comment earlier when we were doing a walkthrough about design and aesthetics. talk about it. I'm curious where that fits in your idea for the company.
Yeah, it's actually a clash I have as an individual between the two. And I mean, it's a running joke. Your engineering and industrial design is always sort of at odds. I think really good designers, their job is to align the two. For Mach, it is important that your products convey their purpose. And the purpose of our products are to deter conflict. And so if part of that is conveying lethality, I actually think that's a very, very important portion of sort of the mission set of your product. But we also design things that fly several hundred miles an hour through the air, which constrains shape a good bit. And so, yeah, we care deeply about industrial design. We have like automotive quality surfacers to make our aircraft look good. Glide is not surfaced during the walkthrough. That was done by one of my buddies from college in like a day and a half because we had to get ready for a customer demo. The next one will be. But we've invested heavily in it. But at the end of the day, we're an aerospace company. And in performance and mission set capability will always win out.
Yeah, they dictate sort of as much as you might like a design.
But that almost makes it harder for the designer in like a very interesting and challenging way. Like I found that the best designers are actually motivated by that because it's just another constraint, right? It's another piece of the puzzle that they have to go and solve.
Yeah.
What does the competitive landscape look like in this space? Are there other folks working on mass production in the same way? What does that look like?
Yeah, absolutely. I mean, obviously, Anduril has unmanned systems. They're an incredible company. I think the work Firestorm is doing is very, very exciting. At the end of the day, like I see us all on the same team, driving towards like providing for American defense. We'll go and build whatever our platforms are. They'll build whatever their platforms are, and ultimately the customer will decide.
What's your plan looking forward 5-10 years down the line? Where would you like to see Mach at that point?
I think success is certainly shipping like the best product in the world to go and provide for American defense. And so I want to have shipped tens of thousands of Vipers or whatever that ends up looking like. I think the stratosphere is the most important domain of the next century. And so I want to have created dominance for America in the stratosphere. And then as a company, I would like to be sort of a dominant player in aerospace manufacture with a clear play on continuing to scale for the next 50 years.
A question I have for you as I'm thinking through all this stuff is, so we've talked about the manufacturing side of things, then the software and the industrial design. A lot about just manufacturing is like learning the finance of manufacturing. So how did you learn that, or how have you been learning that? Was that something else you grew up kind of knowing or being around about, or is that a newer thing?
I actually love finance, like of our spent in the company. And this feels like sacrilegious to say this as an engineer, but I enjoy it a lot. My dad does finance, and he's been like pretty obsessive with trying to instill that with me. Right now, most of our work is on just forward-looking modeling. Just comparing cost curves of different means of production. It's not automated right now, right? Like right now it is me, our head of finance, and our head of manufacture sitting in a room for 12 hours and going through literally different line designs and different means of scaling. It's definitely an area to continue building out. I am super happy with, as I'm going to nerd out here, but like we've built a really, really cool like spend structure and sort of authority system as a company. And so we can actually reconcile our books in like a day or two, which is super, super meaningful. And then all of our spend pretty much directly flows into our finance models that we have as a company, which are pretty in-depth. So I can compare different scaling cases sort of real time with investors. And so, I mean, it's robust. We'll continue to build it out, but you're exactly right. Like when we look forward, the hardest part of manufacture might actually be the financial side of keeping it flexible and being able to afford this CapEx.
As you guys continue to develop technology, I think Kevin earlier mentioned this, and you referenced it too. There are potential downstream commercial or domestic effects of the technology you build. Can you hint at what some of those might be, or just generally more broadly, what you think in the domestic side is up for grabs as well, and you hope technology improves over the next couple of decades?
Yeah, I would say I almost certainly think there will be, but we're pretty focused. I mean, we're entirely focused right now on the defense market. Yeah. Like I think it's hard as a startup if you're bouncing around too many things to be successful. Entering the DoD market's super hard, and so not spending a ton of cycles on it.
Yeah, that makes sense. As far as like a lot of drone UAV, I mean, there's feels like every other week I see a new drone or drone adjacent startup. Are there new technologies or new methods of production or new, emerging availability of like materials? You mentioned like we saw the 3D printing station earlier that is driving a lot of this surge in drone production manufacturing, not just here but also in the world.
Yeah, incredible question. I think it all starts with the base autonomy layer. So like we're writing our own flight controller. That's relatively new to be able to do that cheaply, like for a couple $100 a unit. And Ukraine, to me, the most important takeaway of Ukraine has been sort of how important the RF side is and how important electronic warfare is. And we've seen costs on those platforms go down like crazy. And we'll be playing in that space, obviously. The small turbojet market is super interesting. So we're building our own engines for Viper. Frankly, we're mostly doing our own engines for Viper as a means of like developing that propulsion team to go and attack sort of more complex propulsion products. But I think the air breathing engine market and the sort of efficiency you can get with that, or I guess more energy density you can get with that, is super exciting. Yeah, I think it's a combination of many different things.
Yeah.
Are there any particular lessons that have come out of the Ukraine conflict that you all have noted and are applying?
Tons. I mean, so we're setting up, we full-time Ukraine team. I've been over there. We have consultants who are fighting with Ukraine right now, sending us back information. Any design trade we make right now, we're reviewing, specifically on the avionics electronics end, we're reviewing with the Ukrainians. At a company level, it's just reaffirmed how important iteration speed is. Like when I was over there were literally people like spoofing and stealing Russian drones, ripping out the avionics, putting their own avionics in and sending it back.
Wow.
And so continues to prove how important iteration rate is on all the RF side, especially. I think the artillery side has been super interesting. So like as someone who wanted to work on guns in like 2019, we were actually massively divesting in artillery. The how prolific artillery has been, and sort of the mesh between super cheap ISR coming from drones and the ability to, again, at scale, drop artillery on target has been really interesting. And we'll obviously be pulling that thread with long range artillery systems at some point in the next decade. That's another big one. And then just cost, right? Like it has become incredibly clear how cost conscious we're going to have to be if we're going to have to fight a near peer conflict. That's where U.S. companies have struggled most, right? Is being able to have like operational significance on a dollar per dollar basis.
The Houthis, the conflict with the Houthis has sort of shown this, where they're, launching drones and sinking multi-million dollar. Yeah, that's unbelievable. So what does the other side of that look like? Not just the counter-UAS, counter-UAV. Like, how do you? We've talked to a lot of founders who are thinking about this problem. Some with laser systems, some with net that captures a drone, some with there's Allen control systems that uses a new arm that shoots, they mount a M240 on and shoots 308 and tries to have a particularly targeted system to take the drone out. What does that look like from your perspective? A world where drones are so cheap and so easy, not just our capacity to produce them, but the enemy's capacity to produce them. How do we defend against that threat?
It's an incredibly hard problem. Frankly, it's a problem that we aren't working to solve as a company. I think the work that other players in the space have done there is far further ahead than we could be in the next few years. It's going to have to be a combination of systems. I think it's primarily kinetic, gun-based, or drone-based.
Drone v drone?
Yeah.
Nice.
You see this. Anduril obviously has Anvil and Roadrunner, which are both like pretty capable platforms for doing this. I don't know. It's a really hard unanswered question. But as a country right now, we don't have either, right? Like we don't have the production capacity to be able to produce thousands of these things to create significant risk for an adversary. we also don't have the ability to defend against an adversary that's sending thousands of these our way. We as a company are mostly working on solving the former.
What does the next 3 to 6 months look like for you guys? What's top of mind?
Yeah, so hyper aggressive push on Rev B of both vehicles. So again, back to the whiteboard, trying to in the next 3 or 4 months get those flying full mission set sort of capability. For Viper, that'll take longer than 3 months to get to sort of full demonstration. Big emphasis on public marketing. We've been very, very quiet. Again, that hasn't necessarily been intentional. I just think there have been more important things to work on in the near term. But I'll be making a push in that direction as a company. Frankly, on the ops side and a lot of the business, we're already at the scale that we'll be when we raise the Series B, and so not a ton of hiring build out on that end. Probably doubling the size of the engineering team in the next 6 months, and then getting ready to scale production, which I'm very excited for.
That's sweet. So if we were to show up in 6 months, that room is filled, or at least more full than it is right now.
Probably more full. I can't say. So like we could fill it in 3 months if we wanted to. I'm sitting back with our investors and we're tracking sort of on a month-to-month basis when it makes sense to pull the trigger.
Makes sense.
Exciting stuff. Ethan, thanks for joining us.
Thanks for having me.
Thanks, man.
It's been fun.
Yeah.